We're factoring simple trinomials here. Simple trinomials are ones that have the format of an x squared plus bx plus c. So the coefficient of the x squared is actually a 1 to make it simple. If there's a number other than 1 there, it's no longer considered to be a simple one. It's more of a tricky trinomial. That's what I call it anyway. But before we begin our actual factoring of the simple trinomials today, I want you to review or remember what we were doing last time when we were factoring by grouping. So I'm asking you here to factor by grouping, factor the following, and we talked about having the 4 terms here and pairing things up and looking for common factors within the pairs. The type of factoring you always want to look for first is common factoring, but if you notice, these examples have nothing in common with all of the terms here. So factoring by grouping is our next type to try. Once you finish that, just do the number 2, which is expand and simplify. Just straight up multiply the two binomials together, get the answers, and then look at the patterns. See if you can answer the questions below there. And then I'll go through that with you. But put me on pause for now. Try as much as you can, and then check your work afterwards. Okay, if you check your work on the factoring here, I paired up my first two and then my last pair, and then I ended up with an x plus 2 and a 2x minus 3y, sorry, plus 3y here, so x plus 2 and then a 2x plus 3y. Hopefully that works for you. I paired up the first two and then the last two together, and I common factored x out of the first pair and a minus y out of the second pair. I've got a 2x plus y and then an x minus y as my factors for that one. My third one, now I could have combined the plus 4x and the plus 3x, but I didn't, only because I asked you to factor by grouping. I took an x out of the first pair and a plus 3 out of the second pair. That leads us to the x plus 4 and x plus 4, which factors to the x plus 4 times the x plus 3. Now, this next one only has 3 terms, and I mean, I could try pairing up the first two, but then I've got nothing to put with the 12 at the end on that one, so it's kind of crazy. But I'm going to lead you back to this example right here, number 3. Do you notice that if you would have combined these two terms here, the 3x and the 4x, they actually equal this plus 7x. And the rest of it is all the same. I have an x squared and a plus 12 on the end. I have an x squared and a plus 12 on the end of this. So what we're going to do is when we're working with these simple trinomials is we're going to look for ways that we can actually take that middle term, that 7x, and figure out, could we break it down into things like this 4x and the 3x? And how does that work? Okay, so that's where this next slide leads us to. If you look at how you expanded and simplified, notice we got our x squared and our plus 7x, and then we have our plus 12 on the end. I oopsed on that. Good thing I'm checking this over. Give me my eraser here. Let me fix that. Make those plus 12s and a plus 12. So do you notice that this is the example, and really with factoring, we're starting with this bottom step, and what we want to do is work our way backwards up to this top step here where we have that factored form, one thing times another thing. So the question is, how do we work this backwards? How do we get that 7x to break into the 3 and 4? How do we know it's not 6x and 1x? Or how do we know it's not 5x's and 2x's? How do we know it's going to be our 3 and 4? So that's what we need to look for. Figure that out. Likewise, this minus 3x really is the sum of positive 4x and a minus 7x. How do we work that backwards? How do we know it's going to be a positive 4 and a minus 7? So how do the first and last terms of each answer relate to the original binomials in each part of question number 2? So if you look at this first term, the first term is the x squared term here. Every time I get a 1x squared, every time. And that really comes from multiplying the x at the beginning with the x at the beginning, the x at the beginning with the x at the beginning, x with the x. So that's where those are coming from. If I look at this last term, which is positive 12 here, it really comes from multiplying the 3 with the 4. The minus 28 really comes from multiplying the minus 7 with the positive 4, and the positive 8 comes from multiplying minus 2 with minus 4. Okay, so that's where the first and the last terms of each answer come from. Now, the question is about how does this middle term of each of your solutions relate to the original binomials? Well, here I have positive 7, and here I have a 3 and a 4. Here I have a minus 3x, or a minus 3, and here I have minus 7 and a plus 4. Minus 7 plus 4, positive 3, positive 4. A minus 6 here, broke into a minus 4 and a minus 2, and here's minus 2 and minus 4. Well, really, when you're factoring a trinomial, you're doing the reverse operation of expanding. So we're really working backwards, and that 7 is coming from the x times the 4x. So up here, the x times the 4x. The x times the 4x is what's giving us the 4x, and then the 3 times the x is what's giving us our 3x. So these two numbers in here really are also the two numbers that will multiply to this last term. Okay, so it becomes a number game, and hopefully your number facts are good, because this really relies on good number facts, knowing your number facts very well. When I'm factoring something like this first one, I will be looking for two numbers that are going to add up to give me 7, but at the same time those two numbers have to multiply together to give me 12. So 3 and 4 work for that. For the second one, I'd be looking for two numbers that multiply to give me negative 28, but at the same time, they have to add up to give me negative 3. In the last one, I'm going to be looking for two numbers that multiply to give me 8, but add up to give me negative 6. All right, so before I go to my next video on this and we actually put this into play, I'll type up what I think you should have for answers. It doesn't have to look, yours doesn't have to look the same as mine, but just in case you didn't quite catch what I was saying, I will summarize what I've said here.